November 1942. The North Atlantic, an area British sailors grimly called the Black Pit. Here, in the frozen heart of the ocean, the laws of the land didn't apply. There was only steel, cold, and will. On the surface, tossed by giant waves, was the German U-boat U-505. Inside, in the cramped space that smelled of diesel and unwashed bodies, there was the confidence of a predator. The commander, Klaus Richter, a veteran of dozens of patrols, stared at his map. His wolf pack had just torn apart an Allied convoy. 2 merchant ships and a tanker were on their way to the bottom. The crew was at peak efficiency. They were invincible. A young radio man, a boy of 20 with fanaticism in his eyes, listened to the airwaves. He was the best in his class. His ears could distinguish the engine of a British destroyer from an American one at 10 miles. But now he caught something different. Not a sound. It was a strange, pulsing electronic signal. Low frequency, unstable, almost fading into the storm's noise. He fiddled with the dials for a few minutes, then took off his headphones and turned to his captain with a smirk. "Captain, the Americans are playing with their toys again. It's their new centimeter band radar," he reported. His face held the contempt of an expert looking at an amateur's work. Richter came closer. He was old school. He believed in the periscope, in the sharp eyes of his first officer, and in the magnificent Carl Zeiss optics that turned night into twilight. He didn't trust these newfangled electronics. "And what does their miracle weapon see?" he asked, with poorly concealed irony. The radio man laughed. A quiet, confident laugh from a man who knew his business. "It sees interference from the waves, Captain. The signal is unstable. The picture on their screen must look like a snowstorm. Judging by the power and stability, they couldn't tell our boat from a small iceberg, even if they ran right into it. It's primitive. They're trying to see us with a saucepan and some wire." A restrained chuckle went through the control room. The crew, exhausted from days of tension, gladly seized the chance to feel superior. They were the aristocrats of war, the hunters of the sea. And the Americans? The Americans were just farmers and factory workers, dressed in uniforms and sent to a war they didn't understand. They built their ships like cars, by the thousand, but they had no soul, no instinct. Commander Richter nodded, satisfied. He looked out the porthole at the raging ocean again. The storm was his best ally. No eye, no binocular could pierce this curtain of rain and spray. And a primitive radar? It was laughable. Just more proof that the Americans were trying to replace skill with quantity, genius with the assembly line, artistry with brute force. "Very well, keep monitoring," he snapped, and returned to his map. In his mind, the subject was closed. The threat did not exist. They laughed. They all laughed on that cold November evening. They laughed at the clumsy, blind technology. They didn't know they were laughing at their own future. They didn't understand they weren't looking at a device. They were looking at a symptom. A symptom of a disease for which the entire German war machine had no immunity. That flickering, unstable signal wasn't just a technical flaw. It was a manifestation of a philosophy that didn't demand perfection from a single unit. It demanded an overwhelming, unimaginable number of imperfect units. The Germans were evaluating the weapon. They should have been evaluating the civilization that created it. A civilization that thought not in terms of better, but in terms of more. A civilization that could afford hundreds of failed prototypes to then mass-produce 1,000 working ones. They couldn't see the giant factories in Massachusetts running 3 shifts a day behind that signal. They couldn't hear the hum of assembly lines spitting out these saucepans with wire 24 hours a day, 7 days a week. They couldn't imagine the supply chain that could deliver, install, service, and replace this device on any ship anywhere in the ocean in a matter of hours. They saw one defective radar. They should have seen the industrial might of an entire continent just beginning to wake up. This wasn't just a device. It was the first drop in a steel tsunami that, within a year, would crash over the Atlantic and wash all of their wolf packs from its surface. Commander Richter gave the order to dive. The heavy hull of the U-boat slipped smoothly beneath the waves, into the saving silence of the deep. The diesels fell quiet, the silent electric motors engaged. Above, the storm raged. Below, there was calm, and the certainty they were right. They were safe. So they thought. But at that very second, on the pitching bridge of the American destroyer USS Drayton, 100 miles away, a young radar operator stared at his screen. He too saw the snowstorm. He too struggled to tell the interference from a real signal. But amid that chaos, for just a few seconds, a tiny, barely perceptible blip of light held steady. It was faint, it was fuzzy, but it was there. And he, this operator, didn't need the intuition of an elite U-boat commander. He didn't need years of experience as a sea hunter. All he needed was that dot on the screen. And an order. Within a year, there would be no one left to laugh in these waters. This is the story of how mockery became an epitaph. To understand how this blind mole learned to see, we have to go back to 1940, to the quiet, sunlit halls of the Massachusetts Institute of Technology. Here, far from the roar of explosions, another war was being fought, a war of minds. The Atlantic was becoming a massive graveyard for Allied ships. German U-boats, operating in coordinated wolf packs, were sinking hundreds of thousands of tons of cargo every month. Britain, cut off from its colonies and from American aid, was slowly suffocating. The main problem was the so-called mid-Atlantic gap, a vast area of the ocean beyond the range of land-based aircraft. In this darkness, the U-boats were kings. Existing radars, which operated on meter-long waves, were too bulky and imprecise. Their beams were too wide. They could spot a plane or a large ship, but detecting the small, semi-submerged conning tower of a U-boat, especially in a storm, was nearly impossible. A breakthrough was needed. A beam as sharp as a surgeon's scalpel. That's when MIT's Radiation Laboratory, or the RAD Lab, entered the scene. It was one of the strangest and most brilliant scientific collections in history. The name was chosen deliberately to confuse spies. It sounded harmless, like a nuclear physics department. In reality, it was the nerve center of the American radar program. Hundreds of the nation's best physicists, engineers, and mathematicians were gathered under one roof with a virtually unlimited budget and a single mission: learn to see in the dark. Their ace in the hole was a British invention, the cavity magnetron, a small copper-colored device that could generate powerful centimeter-long microwaves. The British had invented the brain, the Americans had to build its body, and the body they built for it was ugly. Thus, the SG radar was born. This was no elegant engineering solution born of a flash of genius. It was a monster stitched together from compromises, haste, and thousands of man-hours. The first prototypes, assembled in 1941, were a nightmare for any ship's engineer. The equipment weighed nearly 1.5 tons, as much as a small car. It required 50 kilowatts of power to run, enough to light up a small city block. The rotating antenna was bulky and vulnerable to storms. And inside, in the cramped operator's hut, was the heart of this beast, its display. This was not a modern screen drawing a clear map. It was an A-scope, an oscilloscope with a dim green line running across it. Any object would reflect the signal and create a spike, or blip, on that line. The operator had to interpret this dance of light like a fortune teller reading tea leaves. A tall, sharp blip was probably a large ship. A quivering mess of dozens of tiny blips was sea clutter, reflections from the tops of the waves. And somewhere among them, barely distinguishable from the noise, might be the tiny spike of an enemy submarine. The first tests aboard the destroyer USS Semmes off the coast of Boston were a farce. In even a light swell, the screen turned into a green mess of static. The equipment constantly broke down from the vibration and the shock of the waves. Tubes burned out, fuses blew. A visiting officer from the British Royal Navy, accustomed to more reliable, if less powerful systems, sarcastically remarked, "Gentlemen, I hope you plan to scare the Germans to death with your light show, because you certainly can't see anything with it." Even within the U.S. Navy, the professor's toy was treated with skepticism. Old sea dogs, admirals who had come up through World War I, believed in trained lookouts and the power of 16-inch guns. They watched the fussy, bespectacled engineers and thought they were trying to replace centuries of seamanship with a questionable electronic magic trick. A joke made the rounds about an SG operator who confidently reported contact with an enemy cruiser, which turned out to be a rock off the coast of Maine. The project looked like a costly, ambitious failure. It was consuming millions of dollars and thousands of hours from the country's best minds, and in return, it produced a bulky, unreliable, and finicky device that was nearly impossible to use. And everyone was meant to believe this. The Germans, the Allies, even you, the viewer. Because hidden in this ugliness, in this apparent weakness, was the core secret of the American war machine. A secret that Germany would never solve. They saw an ugly duckling, but they couldn't see the giant, ruthless system standing behind it, preparing to turn it into a weapon of the apocalypse. But while German officers were laughing in the Atlantic, back in America, no one considered the SG radar a failure. They didn't see a flaw, they saw potential. And in this lay the fundamental fatal difference between the two systems. The German engineering philosophy was a cult of perfection. It sought to create the ideal weapon, precise, complex, flawless. Each Tiger tank was a work of art, each U-boat a masterpiece of custom craftsmanship. But art doesn't win wars when it's up against mathematics. The American philosophy was different. It was the philosophy of Henry Ford, taken to its absolute extreme. Why spend a year creating one perfect sword when you can forge 10,000 perfectly good axes in the same amount of time? Perfect is the enemy of good, especially when you have 1,000 times more good than your opponent. And the SG radar was the ideal candidate for the role of the good axe. It was imperfect? Great, that means it can be simplified. It was bulky? It doesn't matter, our ships are big enough. It was unreliable? We'll make it modular, so any broken part can be replaced in 5 minutes, not repaired for a week. And so the machine began to turn. The contract for mass production was given to the Raytheon Company. What happened next wasn't engineering anymore. It was an industrial juggernaut. Forget the quiet labs of MIT. Picture a giant factory floor the size of several football fields somewhere in Waltham, Massachusetts. A factory where the lights never go out. 3 shifts, 8 hours each, 24 hours a day, 7 days a week. Thousands of women, yesterday's homemakers, teachers, and librarians, stood at the assembly lines. They weren't brilliant physicists. Many of them were holding a soldering iron for the first time. But they didn't need to be geniuses. The system was designed so that each person performed one simple automated task. One woman soldered a capacitor. The next twisted a wire. A third tested a circuit board. Over and over, thousands of times a day. It was a hypnotic, soulless rhythm. Click, turn, solder, pass it on. An assembly line humming like an army. And this is where the numbers begin. Numbers that the German general staff, even if they had received them, would have dismissed as propaganda, because they didn't fit into their worldview. It took the Germans about 6,000 man-hours to build one Panther tank. At the Detroit Arsenal alone, the Americans were producing 12 Sherman tanks a day. 12! Every single day. Over the entire war, Germany built just over 1,300 Tiger I tanks. In the same period, America produced nearly 50,000 Shermans. But back to the radars. By the end of 1943, Raytheon and other contractors were producing not dozens, but hundreds of SG sets a month. By the end of the war, over 20,000 systems had been made, enough to equip every warship, every transport, and even some tugboats in the entire Allied fleet. But production was only the first beat of this industrial rhythm. Next came logistics, America's secret weapon, more terrifying than any atomic bomb, because it always worked. Each radar was packed in a sturdy wooden crate with a full set of spare parts and, most importantly, an instruction manual as simple as a comic book. These crates were loaded onto Liberty ships, another marvel of mass production. Ships that were built not in months, but in days. The record was 4 days and 15 hours from laying the keel to launch. These ships carried the radars to England, Iceland, Gibraltar. At every major naval base, a warehouse of spare parts and a repair shop were set up. And here, the American philosophy of replace, don't repair, revealed its ruthless efficiency. If a destroyer came back from patrol with a faulty radar, no one wasted time diagnosing the problem. A team of technicians would simply remove the entire unit and install a new one from the warehouse. The whole process took 2 or 3 hours. The old unit was sent to the workshop, where it was repaired at a leisurely pace and prepared for the next ship. A damaged German U-boat had to limp all the way back to its base in France, wasting weeks of precious time. An American destroyer was back in the fight in a matter of hours. This was a war not of ships, but of systems. The German system was fragile and centralized. The American system was flexible, decentralized, and possessed a near infinite capacity for regeneration. They weren't fighting an army. They were fighting a civilization that had turned war into an industrial process. While a German engineer proudly stamped his personal mark on a perfectly assembled torpedo mechanism, an American worker just checked a box on a form, sending the 100th standardized electronic module of his shift down the line. And in that faceless, routine gesture, there was a greater threat to the German government than in all of Churchill's speeches. The industrial rhythm of America was becoming a funeral march for the German U-boat fleet. They just couldn't hear the music yet. But soon, it would be deafening. And then it happened. 1943, May. A month German submariners would forever remember as Black May. Off the coast of America, in the Gulf of Mexico, in the North Atlantic, everywhere their wolf packs had once ruled, there was now terror. And this terror didn't come from sea monsters. It came from ghosts that appeared out of nowhere. By this point, SG radars had been installed on the vast majority of escort ships. They weren't perfect. Sea clutter was still a problem, but they worked, and they worked well enough to do the impossible. Picture a German U-boat, surfaced at periscope depth in the pre-dawn twilight. Fog, drizzling rain, perfect hunting weather. The watch crew is tense, but confident. Visibility is a few hundred yards at best. No optical instrument can help. They are invisible. But suddenly, as if from thin air, an American destroyer appears. It's heading straight for them, though it shouldn't have seen them in this weather. And it's not just approaching, it's attacking. Torpedoes, depth charges. The commander of U-644, Lieutenant Hermann Gunter, described it in his report. We surfaced to recharge batteries at 0315. Visibility was 0 in a storm. Approximately 15 minutes after surfacing, with 2 hours of charging still to go, we were attacked by an unknown vessel. It appeared out of the fog like a phantom. We did not see it until the last moment. We do not understand how it could have detected us. This was not an isolated incident. Similar accounts began to pour in from all over the Atlantic. From the War Diary of U-515, May 12, 1943. At 2300, on a calm and clear moonlit night, we were attacked by 3 destroyers. They came straight for us, even though we were surfaced and maintaining maximum concealment. They opened fire from at least 15,000 meters. We could not understand how they found us. Enemy radar, probably. Probably. That one word became the symbol of the end of German dominance at sea. The Germans were soldiers, accustomed to duels. They understood honor, they understood skill. They could not believe they could be detected simply because someone flipped a switch. One veteran submariner, Commander Paul Schmidt, later recalled, "We were stunned. We were being hit and we didn't know where the blows were coming from. It was worse than sailing into a minefield. It was humiliating." And here is the contrast that would break the German spirit. A story told by a captured German officer to his American interrogator. "We were on patrol," the prisoner said, "and our fuel was running low. We had one last canister which we were saving for an emergency. We had to conserve every liter. And then we were attacked, and we saw one of the American ships, after forcing us under, fire several torpedoes that missed. And when the fight was over, we saw another American ship that had been chasing us simply dump the rest of its fuel into the ocean. Because they had nowhere to put it. They had so much fuel they could afford to just pour it out to make room for new supplies. The laughter that echoed through U-boats in 1942 had long since faded. Now there was only shock and disbelief. They were used to scarcity, to rationing, to the idea that every torpedo, every shell casing counted. And here were their enemies just dumping fuel. This wasn't just technological superiority. This was a superiority of resources, of abundance, of the very industrial might they had once ridiculed. The rhythm of history accelerated. A strike, a German U-boat sinks a convoy ship. A pause, the crew celebrates. The next strike, that same U-boat is sunk a day later, detected by radar before it can even fire its torpedoes. The emotion, shock, fear, confusion. The number. In May 1943, Germany lost 43 U-boats. That was 25% of its entire U-boat fleet. In June, another 37. In July, 28. This was the end. The Americans hadn't pursued the perfect radar. They had pursued quantity. They made sure every ship, every plane had this imperfect tool. And when there were thousands of these tools, their imperfect tool became a perfect weapon. They could see the enemy where the Germans believed they were invincible. They could see through the fog, through the night, across hundreds of miles of ocean. They could see them because they had enough eyes, far too many eyes. And in this abundance, in this ruthless mass production, lay the ugly secret. The secret that the German officers understood far too late. They thought they were fighting a navy, but they were fighting a factory. And as it turned out, the factory could see in the dark. In late 1943, the Germans finally got a lucky break. During an operation, they managed to capture a nearly intact American destroyer escort, and with it, the mythical, hated SG radar. It was dismantled with extreme care, like a priceless trophy, and sent to Germany, to a secret laboratory near Berlin. The finest minds in German engineering gathered to dissect and study the heart of the enemy's miracle. They expected to see a revelation, a complex, brilliant design, years ahead of their own work. They prepared to dissect a masterpiece. When the radar's casing was opened, a silence fell over the lab. But it wasn't the silence of awe. It was the silence of bewilderment, and then contempt. Inside, there was nothing ingenious, no elegant solutions. Instead of fine, neat soldering, there were thick, clumsy cables. Instead of perfectly machined parts, there were stamped metal blocks that looked like they'd been cut with an axe. The components were connected with simple plugs, like a child's construction set. It all looked crude, cheap, almost vulgar. One of the lead engineers, a man who designed the most complex optical systems for periscopes, walked around the device and said with disgust, "This is not engineering, this is plumbing." And in that one sentence was the essence of their fatal mistake. They looked at the SG radar and saw only its technical crudeness. They missed the point. They couldn't see the philosophy behind it. This device wasn't built to be admired in a laboratory. It was built to be assembled by the thousands on a conveyor belt. It was built so that any technician with minimal training could replace a broken module in 10 minutes, at sea, in the middle of a storm. It wasn't built to be perfect. It was built to work. And there were always more of them. In that sterile German laboratory, what took place was not a technical review. It was a collision of two civilizations. The civilization of the workshop, where a lone genius creates a masterpiece, and the civilization of the factory, where a faceless system produces an endless stream of products. And the factory won. Grand Admiral Karl Donitz, commander of the entire U-boat fleet and the architect of the Wolfpack tactic, was finally forced to admit defeat. In his final report, he wrote with a soldier's bluntness, "The enemy has deprived the U-boat of its essential feature, namely its invisibility. He has achieved this not only by means of aircraft, but primarily through his superiority in radar. The enemy possesses methods and means that make our struggle impossible. It was a confession, as cold as the Atlantic water. The enemy had won not because his soldiers were braver, but because he had a weapon that made bravery irrelevant. A weapon that turned the ocean into a floodlit arena with nowhere to hide. The SG radar was just one symptom. In the same way, German tankers adored their Tigers and Panthers, deadly, nearly invincible machines. And in the same way, they watched in horror as for every one of their knocked-out Tigers, 10, 20, 30 American Shermans came over the hill. Cheap, simple, mass-produced. Each one weaker individually, but together they were a steel avalanche that simply crushed them with statistics. Germany fought a soldier's war. America fought a war of spreadsheets, a war of logistics, production, and statistics. While the German General Staff planned brilliant tactical maneuvers, the Pentagon planned production cycles and supply routes. And in this war, numbers proved stronger than genius. In the end, the enemy understood. They weren't fighting an army. They were fighting a ruthless, soulless, but incredibly efficient industrial civilization. A system for which a broken radar wasn't a tragedy, but just another line item in an equipment replacement report. A culture that didn't create weapons, but stamped them out like disposable cups. The SG radar was not a work of art. It was a death sentence, stamped from steel in a factory in Massachusetts. This machine, installed on thousands of ships, wasn't just sailing the waves. It was moving according to the laws of large numbers, production charts, and the rails of relentless logistics. And in that cold industrial rhythm, there was no room for the romance of the sea wolf or the heroism of the individual, only for numbers. And the numbers were on the side of the factory that won. They laughed.
Then they fell silent. And then they were simply gone, wiped from the ocean map by an impersonal blip on a green screen.